Thank you very much for the invitation. Today I'm going to give a brief report about what currently in this field to highlight climate change impact human health and disease development, and also some of my representative work and also from one of my colleagues. We all know that climate has both direct and indirect impact on human health and disease development. And there is a long list in terms of climate change on human health and disease development, both on infectious diseases and non-infectious, especially chronic diseases globally and domestically. We are all facing primarily about cardiovascular disease and cancer developments. This is published several decades ago as a landmark paper in New England Journal of Medicine to study those dirty particles in our ambient air, especially the small particles with diameter less than 2.5 microns, which is half of our red blood cell diameters. Indicating that the dirty air particles really induce human mortality, especially from cardiovascular disease. One of the six US cities in Ohio is called Steubenville. At that time, which was the most polluted city in the United States, represents how the PM 2.5, we call it, the fine particulate matter induced mortality in human health. Another paper indicates, again, the smaller particles that cause it when it's at relatively low concentration. It causes associated well with cardiovascular mortality, while it's in a high concentration, such as in those developing world right now, it's strongly associated with cancer, especially lung cancer development. Especially in health and disease study, we think the smaller particles in the ambient air that primarily released from fossil fuel burning, that's more associated with human disease because they have the potential to penetrate the blood-gas barrier and going whenever the blood supply goes into the remote organs and the tissues that cause chronic long-term negative impact on human health. Another air pollutant is ozone that has been becoming more challenging in this field. I think you know better than me. Primarily, I think there are several impactors. One would be it's difficult to determine how it's released because it's indirectly generated when it's in the ambient air. So this another landmark paper in New England Journal of Medicine indicate that long-term ozone has more mortality impact on human health, primarily from respiratory disease comparing to the particles that's more associated with cardiovascular and cancer disease development. So another, I think, a highlight as a representative paper that climate change, especially the global warming temperature change, is strongly associated with even with the gender change impact more, which means the male is more susceptible than female in terms of male-female ratios. That's one of the studies published from Japanese scientists. We are fortunate to have this kind of exposure facilities located at OSU. So one of these we called Oasis 1. So we could suck the ambient air, isolate the smaller PM 2.5 particles and expose to animals, especially rodents, for short-term and long-term impact to see how those the locally generated particles where you and me have been inhaling all the time, how that impact the health and the disease development. So one of the study from my group published in JAMA was we were the first to publish for half-year exposure to a rodent and showing that exacerbate atherosclerosis. That's one of the major cardiovascular diseases and the vascular inflammation. And the worst is if the mice were exposed to dirty air and with high-fat diets. We compared the high-fat diet with normal diets, and they had the worst on the very right. They have the worst, the most atherosclerotic change in their aortic section, comparing to the one of the group with the clean air that could filter out the dirty particles with normal diet. So indicating that the high-fat diet would really exacerbate the dirty air impact on atherosclerotic change. So after that, we further studied the adult mice with also, again, high-fat diet to indicate, since we all know that globally and domestically, overweight and obesity is becoming a challenge, especially in the United States. So we find out really the dirty air released primarily from fossil fuel exacerbates the adipose inflammation, especially the visceral adipose in our belly, and insulin resistance. That's the hallmark of type 2 diabetes in this mouse model. So we could show that from histological morphological examination, we saw that the dirty air causes more macrophage infiltration in the white adipose tissue and enlarge the adipocytes in those white adipose tissue as well. So furthermore, we studied not only the single air pollutant, but also the combined, the co-exposure with PM2.5 and the nickel. We know nickel is one of the major heavy metals chemical components in those smaller particles. We systemically investigated how those co-exposure impact increase insulin resistance and mitochondrial dysfunction in this mice model. And also another co-exposure is the PM2.5 with ozone. That's especially representative pollutants occurring, especially even here in Columbus or Cincinnati, Cleveland, Central Ohio, or Midwest. During the summertime, we are exposing to both PM2.5 and high concentration of ozone. So we also studied quite a few in human. One of the study was conducted in Beijing, China, where China has been experiencing economical surge, but also suffering a lot of air pollution impact. So one of the study indicated that black carbon, when it's substantially increased, is strongly associated with vascular constriction that's directly impact the increase of blood pressure in human study. So we talk a lot about global warming. That's certainly happening. And then we already see a lot of negative impact from the temperature change. Then how to deal with that? So one of the study in my lab indicated that the intermittent cold, lower temperature exposure to the rodents could improve glucose homeostasis. That's strongly associated with improving in insulin sensitivity, that could be one way to deal with insulin resistance or type 2 diabetes. So a few slides from Dr. Lee in my division, who can't be here, to highlight her work about pathogen exposures primarily caused by climate change. And she has been doing quite a few works primarily in state of Ohio with the lake, pond, water, studied the pathogen in that. One of the study, even inland beach, to see the association of GI illness caused by recreational water exposure. Another paper indicate more of both bacteria and the virus associated with water quality in those freshwater beach, indicating that we all know that the climate change would certainly in certain area increase the precipitation that directly causes more fecal contaminations. And then certainly strongly directly associated with GI illnesses. So that's water contamination with human health. Another one, I think she has been studying quite a few in terms of algae blooms, primarily in the state of Ohio, associated with health impact. One of her study published about a 10-year survey in Ohio. Water bodies use satellite remote sensor that I know with a few, perhaps some of you are sitting here conducted in Ohio. And one of her PhD student also published, indicated that the algae and the blooms contaminations associated with non-alcoholic liver fibrosis, primarily both evidences from human and animal models. So that's really another, some of her work also associated with some food contaminations. So one of the study indicated that the fresh produce and their soils accumulate cyanotoxins from irrigation water, indicating a strong climate change associated with food security and then impact on human health. So, and one of the data showing that she tested several samples, one with the plant, another would be soil, and some other showing that how the microsystem different concentrations impacted by the water quality as well, that impact the crop productivity and the quality as well, from the length to the mass to the diameter. So really the crop stressed out by those climate change, and directly and indirectly. So that's all for myself and my colleagues. Thank you.
We have time for one quick question. I'm gonna, anyone in the room? Question for professors? Go ahead.
So some of the studies on the mouse model showing linkages between air quality, fatty diet, and atherosclerosis. So things, have you mined the human data, like the human health data, to see if those relationships exist in humans as well?
Yes.
Can you repeat the question?
Yes, the question is how the association, the evidence from dirty air, high-fat diet in human, especially cardiovascular disease. There are tons of evidences, even some biopsies from the human organs and samples indicated that the dirty air embedded in those visceral adipose tissue that incorporated with macrophage increase and increased atherosclerosis. There are tons of epidemiological studies and clinical investigations as well.
Great. Thank you very much.
Thank you.